Greetings, Earthlings! Before we start exploring, don't forget to like, comment, and subscribe, wherever you're listening. It helps more people find the show and supports our mission of making science accessible to everyone. You're here with DJ Stellar Cloud. Thank you for tuning in. Welcome back, explorers, to another episode of the EYU radio show. EYU, or Exploring Your Universe, is UCLA and LA County's largest science fair. Every year, we have over 12,000 visitors, many of whom come to see UCLA's Planetarium, which you'll be hearing about today. You're listening to DJ Stellar Cloud and...
DJ Micron.
DJ Micron, aka Leonardo Clarke, is a PhD candidate at UCLA working with Professor Alice Shapley in the Department of Physics and Astronomy. However, as it pertains to EYU, DJ Micron is the head of the UCLA Planetarium booth, which is definitely EYU's biggest attraction. So, what is it like running the entire planetarium?
Well, I wouldn't say that I'm the head of the planetarium booth. It's a team effort for sure, and I'm slowly kind of phasing out my involvement with the EYU aspect of the planetarium. But I would say that it is a lot of work, but a lot of it is very rewarding. So like you mentioned, there are a lot of visitors to the planetarium during EYU, and because it only seats 50 people, and we can only schedule about 10 shows on the day of EYU, we're only able to accommodate like 500 visitors. So you can imagine, 12,000 visitors to EYU and only 500 people getting to see a show.
Which is
very
kind of insane that like over 500 people want to go see the planetarium.
Yeah.
I think like when I first started grad school, I never would have imagined that this many people wanted to interface with science outreach.
Yeah, I mean, it's something that's very within reach for everybody. I wouldn't say tactile, but it's very tangible. Like, you get to sit down and just see the stars, and it's especially something that's awe-inspiring for people who live in a large city like LA, because you get to see what the night sky looks like without any light pollution.
That's a really good point. I actually don't really know what the night sky looks like without light pollution.
Yeah, well, I mean, come to the UCLA Planetarium, you'll see all about it. But yeah, I mean, it's a good time not only to see the stars, but also to like actually talk with and interface with a scientist, like, right in front of your face. And oftentimes I find, not just at EYU, but at public shows, people will just come with questions that very much seem like they have had this burning question on their mind, and they come to the planetarium and they're just dying to ask, what happens when I get sucked into a black hole, or is the sun going to explode and swallow us all? Or people love to ask about aliens too. So
the aliens of it all.
Mm-hmm.
So I know that you are one of the scientists who is one of the show givers of the planetarium, but that wasn't always true, because I did some internet stalking and I saw in 2021 you said that you might give shows in the future.
Mm-hmm.
So how did you get involved with giving shows, and what is that like?
Yeah, so when I first got here to UCLA, I heard about the planetarium, and I was like, oh, that seems like it'd be really cool, but I was kind of nervous just because, there's the public speaking aspect, and it's also like, okay, I'm going to be talking about some science, so I'd better really know my stuff. And then also, I grew up in the suburbs of Minneapolis, where there's a lot of light pollution.
Minnesota.
Yeah. So I didn't grow up like knowing any of the constellations really, other than like Orion. But then over time, as I assembled a friend group here, we would often go camping in like dark sky sites nearby LA, and that's kind of how I got to learn a lot of the constellations, and with that I gained more confidence to be able to do more shows in the planetarium.
Was there some sort of training of like, if somebody points to this star you can name all of them, or did you sort of have to figure it out for yourself?
I mean, if you point at a really bright star, I know a good number of those, but if you pointed at just any random star, I'm not going to know it. But it's more like I memorize the shapes and the different patterns of constellations, and I can recognize, what it is. And then from some of the really iconic ones, then I can sort of orient myself and figure out where everything else is in relation to that. So that's kind of how I learned, is by recognizing the more famous ones and then learning where everything else is in relation to that.
Okay, so this is kind of interesting because all the planetariums I've seen are relatively newer, like built in the last 10 years. And so they all have this technology now where you can just type in which star you want to go to. It'll zoom in, it'll show you planets. But from what I heard from Natalie, and you can listen to the Natalie episode, it's really good. The planetarium here at UCLA is not at all like that.
Yeah, so good timing actually, because we're in the process of trying to get a new planetarium projector. So the one that we currently have is called the Goto G10X. It's from the 70s. It was installed, I think, in 1973.
Okay.
And at the time, it was sort of state of the art. It has a lot. It's really cool. If you've ever, I don't know if you've been able to see it.
So I haven't been
Okay.
because, and I know this is all my fault. It's because I'm very lazy. I know that there's a free show every single Wednesday, and
Yep.
so my brain is always like, it's always gonna be there.
Oh,
It's
yeah,
always gonna
yeah.
be there. And of course, I never make it actually during EYU because I'm extremely busy
Yeah.
on the day of.
Yeah. Well, I would encourage you to go to our website. I forget the actual link, but if you just type in UCLA Planetarium on Google, then it should take you to our website where you can get tickets to shows. We run shows during the school year, so it's not running over the summer, but during the school year, we run shows.
Oh my gosh! So I missed it again.
Yeah, unfortunately.
Okay,
Yeah.
but anyway, the Goto G70.
The Goto G10X. Yeah,
Okay.
yeah. It rolls off the tongue, but it's this really cool device. It's got a lot of moving parts. It's got like, it rotates around, it moves, and it's got like these lenses that shows different portions of the sky, and it's got
Okay.
these like little shutters to stop light from shining people's eyes. So it's got a lot of...
That's good. It's very safe for the kids.
Yeah, safe for the kids, and it's super cool because it starts moving and people are like, "Oh my god!" And then it starts squeaking, and then people are like, "Oh, it's gonna break," but it's not gonna break.
Are you a musical theater nerd?
I wouldn't say I'm a musical theater nerd, but I know one or two musical theater.
It's just like it's giving
pieces.
Phantom of the Opera chandelier. If you've seen this.
I haven't seen.
Okay.
Phantom of the
It's
Opera.
this giant moving piece like right above the audience, and then halfway through the show, the chandelier like fake falls on the audience. That's what this is giving. Like the squeaking.
No. yeah. No, so getting a new projector, yeah. So the projector itself is pretty cool, and it's a cool like sight to behold, but it's purely analog. So it works just by like having these plates that are in front of a bulb, and then it shines light through these holes in these plates, and that's how it shows what the night sky is
Like
supposed
reverse
to look
shadow
like.
puppets.
Yeah, exactly. And so over the years, things tend to degrade because there's a lot of moving parts. It needs a lot of maintenance. Right now, we're there's a lot of stuff that's broken. There's like a circuit that's broken, so it just like completely took out all of the bright stars. So it's like, yeah. So
Oh no.
yeah. So right now we're in the process of trying to get a new projector, and what that entails is going out, getting quotes from different vendors. The main thing is that we want to say, this is the projector we want, this is how much it's going to cost, and then present that to... There are some donors that are interested in funding the planetarium, which is amazing. So we want to make sure that we have a good idea of exactly how much it will cost, and exactly which projector we want. But we're looking to upgrade to a digital projector. But for now, the analog is it works. It's pretty cool, but with all the maintenance issues that have been happening lately, it's time to upgrade.
I mean, people love this thing. They are waiting in line for hours and hours, and my email inbox is filled with, I really wanted to see the planetarium, but I didn't get to go.
Yeah.
So for anybody like me who has never gotten to go, could you walk us through a little bit of what happens in a show?
Sure. So the format is an hour long for our regular shows. During EYU, it's like 20 minutes in and out.
Yeah.
We're just giving you a sneak peek. But for our regular shows, it's an hour-long format. There's a 30-minute portion in the beginning where the presenter will present either on some science that they're doing or just sort of a general astronomy talk. And it's like a PowerPoint presentation with Q&A. That tends to be one of my favorite parts because I get to talk about some of the stuff that I find exciting. People always have a lot of questions, which is really fun. And then after that 30-minute presentation, we have a night sky show. So the thing that I typically go to, I have like a go-to night sky show that I can sort of run on autopilot in my brain. I take people through the zodiac constellations, and I find that to be...
That's fun.
Yeah, I find it to be fun because it's something that everybody knows. Like if I just point out some constellations that are kind of obscure, people will be like, oh, that's cool, but it's not something that people connect with. Whereas, I can say, who in here is a Scorpio? And then people will
Me?
just, yeah.
I am actually
Wow.
a Scorpio. Are you also?
No, I'm
Okay.
a Taurus.
Okay,
Yeah,
that's funny because your name's Leo.
I know, it'd be great if I was a Leo, but, born in the wrong time, I guess. But yeah, so that's something that people find really fun because it's like, everybody's got a zodiac sign,
Yeah.
but for them to be able to connect that to a constellation is a way for people to, connect in a more personal way to like the night sky and astronomy and all of that. So.
Absolutely. I love that. So are most of the presenters other grad students?
In the past, they've been mostly grad students, but the past couple of years, actually, we've had a lot more undergraduate students giving shows. I think it's mainly because a lot of us grad students have gotten very busy.
Yeah.
And we decided, well, there are a lot of undergrads who are really eager to give shows, so we can, train them on how to use the planetarium. This will be good because it'll give them some opportunities to do some public speaking, improve their research communication skills, and also use a pretty cool facility, which is the planetarium. So it's been a lot of undergrads recently, actually.
No, that's really great. I love that the undergrads here get to get involved with something that's like sort of an input into future careers, because something that I'm really interested in doing now that I didn't know earlier was like working at Griffith and possibly giving those science talk shows. So I would have loved doing that when I was younger. I say younger as if it wasn't like 3 years ago.
Yeah.
But I do like that every show gets a little bit of like flavor from the presenter, and that your flavor is like the zodiac thing. That's really fun.
Yeah. And I noticed, I've been to the Griffith Observatory Planetarium, and I noticed that the show, at least the 2 shows that I've been to, are a lot more theatrical. They're like very, they're very theatrical. This is so, like clearly a professional who is doing more of a performance, whereas I get up there and I'm just like, all right, well, here's the science.
I am a scientist.
I am a scientist. Here's the science. I think there's room for both, but I am not much of a theatrical performer in the sense of the way that they give shows there. I don't know if that's quite my strong suit, but if you want to talk science, I can talk science. That's
We'll definitely get into that soon, but before we close off the EYU of it all, is there like a favorite question or memory that you've had from having the kids in the planetarium? Because you do give shows on the day of, right?
Yeah.
There's you, Hadrian, a few other people.
Yeah. There's a good number of people that sign up to give shows. I think there was it was totally unrelated to science. I think there was a kid, I was talking, and then all of a sudden he just blurts out, "Are you a vampire?"
Wait, why? Is it because it's like dark in there? Like,
I don't remember why, but I just remember laughing out loud, and I said, "No."
I don't understand.
Anyway,
nothing about you gives vampire.
No, not yeah. So I don't know what that was about, but I was so cute. I was like, wow, that's so funny.
That's really funny. You can see my laptop, so I'm a twihard, so I would love to be asked if I was a vampire. That's really funny.
Yeah, give enough shows, and maybe out of the randomness of children's minds, it'll pop up again for you.
That's really funny.
Yeah.
So EYU is a very stressful endeavor. What is something that you have learned from dealing with being the planetarium host at EYU?
Yeah, I've learned, number one, with running something as high demand as EYU, it is helpful for everybody to really have a plan in place for ticket distribution and all of that stuff. If you have a plan in place ahead of time, as opposed to sort of trying to figure things out on the fly, that really helps, because people can get very upset when they're they come to EYU and they're like, I traveled so many miles here and I'm not able to get a show. And along that same note, I think one thing that I learned is that, we can do our best to try to accommodate everybody and make sure people have the best chance possible of getting a show, but it's impossible to give everybody a show.
Yeah, absolutely.
And we're going to be dealing with, inevitably just dealing with a lot of people who are, understandably upset because they just really want to see the planetarium. But one thing that I've learned is, for every person who is upset and expresses that frustration to us, there are, probably 1 or 2 people that had, just such a great time at the planetarium and really found it to be a life-changing experience for the better. So I try to remember that when somebody's frustrated and I'm kind of dealing with that. So
absolutely. Just a friendly reminder, the planetarium is open on Wednesday nights during the school year at 8 p.m. It's absolutely free, and I heard the shows don't really fill up.
Yeah, it depends on the week. Some weeks they fill up. Other weeks there's plenty of room for extra people.
Cool. So you do mention this life-changing experience, and I know what you're saying is that a kid might see the planetarium and then have an interest in astronomy that they pursue for the rest of their life.
Yep.
So how did you become DJ Micron? Did you have one of these experiences?
Well, I became DJ Micron yesterday when I was coming up with the DJ name.
So I know what DJ Micron means, but for our listeners, do you want to explain how Micron relates to...
Yeah, so micron is a unit of measurement. It is 1/1,000,000th of a meter. So you could say micrometer, but in astronomy lingo, I don't know why, but we say micron. The reason why I chose that one is because of the James Webb Space Telescope. So for those who may not be familiar, light travels as a wave, and waves have wavelengths, from trough to trough or crest to crest. We call that a wavelength. For visible light that we can see, the wavelength is somewhere on the order of a few hundred nanometers. So nanometers is 1/1000,000th of a meter. Microns is 1/1,000,000th of a meter, so it's actually longer. It's in the infrared. Now, the James Webb Space Telescope was designed, instead of observing in the visible wavelengths that we see, it was designed to observe in the near infrared, meaning 1 to 5 microns for some of the instruments, all the way up to 25 microns for the mid-infrared instrument. And it's revolutionized our ability to study the universe. The reason why it observes in the infrared, you might wonder, well, why would we be interested in spending a bunch of money on a telescope that can't even see the same light that we see? The reason is because as you look at more and more distant galaxies, because of the fact that the universe is expanding, the light that travels to us from those galaxies travels through the expanding universe, and those wavelengths of the light get stretched out. They physically get stretched out. So it goes from hundreds of nanometers to thousands of nanometers, and 1,000 nanometers is a micron. So the light that you would see with your naked eye becomes only visible in the infrared once you start going to more and more distant galaxies. So that's why with JWST it's really important that we see things in infrared light. So with all of that in mind, I decided that my name should be DJ Micron.
I love that for you. You may be familiar with the effect that DJ Micron is talking about if you've ever been running from a siren vehicle and the siren starts to sound lower and lower. That's because the sound waves are being stretched out, which makes the siren sound lower. I hope your sirens always become lower and no siren vehicles ever chase you. So you're involved with the JWST then. It's a competitive process. It's very difficult to get time on that.
It is.
What is your project and how did you get there?
So the project that I'm working on a few different projects, but the main project that I'm working on is actually working with a public JWST data set. So the team that built and commissioned the NIRSPEC instrument, there are 4 instruments on JWST, and the team that commissioned the NIRSPEC instrument and the NIRCam instrument came together because they built these instruments. They were guaranteed some time to observe on the telescope. So they pooled their time together to put together this survey program called JADES.
Okay.
It's an
NIRSPEC
acronym.
is near infrared spectrometer.
Yes.
Okay.
Yes. And then NIRCam is the near infrared camera.
And near just means it's on one side of it. It's the closer one?
No, near actually refers to the wavelengths that it can observe. So we call it near infrared because it is infrared light that is short enough wavelength that it's almost visible, but it's not quite visible. Far infrared, on the other hand, would be the wavelengths are so long that the wavelengths are sort of far away from what you would be able to see visibly.
And the far is like WISE?
Yeah, or like Sophia.
Oh, okay.
Yep.
Cool. Okay, so public database means that everybody is allowed to access this data?
Yep.
So everybody listening can access JADES?
Yeah,
That's really cool.
if you want to access, there's actually a really cool interactive data viewer. So if you type in JADES, JWST interactive data viewer, then you can sort of pan around, zoom in, zoom out of the images, the NIRCam, near infrared camera images that were taken as part of the JADES program. But for my project, I'm actually mostly looking at the data from NIRSPEC, which is the spectrometer. And the overall goal of the research that I do is to study how star formation in galaxies evolves with cosmic time. So to sort of step back, I mentioned how JWST can look at galaxies that are in the faraway universe, and they're light gets stretched into the near infrared. We call that redshift. One other consequence of galaxies being really far away is that we actually see them as they were in the past. So if you think about the sun, for example, the sun is 8 light minutes away from the Earth, meaning that as soon as light leaves the sun, it takes 8 minutes to reach the Earth, and we see the sun as it was 8 minutes ago. Similarly, the closest star to us, other than the sun, is 4 light years away. So it takes 4 years for that light to travel to us. So we see that star as it was 4 years ago. And so you can take this to the extreme by looking at very distant galaxies, and you actually see galaxies as they were billions of years ago. So if you look further and further back, you can actually look at how populations of galaxies are changing with cosmic time. And with that, you can get a sense of how galaxies grow and evolve. So the work that I'm doing is to look at galaxies at different snapshots in time in the universe and see how quickly they're forming stars, and how that relates to things like their mass.
Astronomy is time travel.
Yeah, exactly. It is. Yeah. When you hear people say that JWST, the James Webb Space Telescope, is a time machine, that's what they're referring to.
So that's like the deep field image that everybody's been posting.
There are multiple deep field images that have been taken with the James Webb Space Telescope, and those are amazing for pretty pictures. But what I mainly focus on are the spectra as opposed to the images.
So spectra are like squiggly lines that tell you which wavelengths of light are the most populous in some image. What specifically are you looking for in these older galaxies?
Yeah, so another way you can think of spectra is if you take light from the sun and you put it through a prism and it makes a rainbow. We're doing that, but rainbow is just visible light, but you can also make a quote-unquote rainbow with infrared light, with all kinds of light. You can, just exactly as you said, you can see which wavelengths are brightest. So the things that I'm looking for in galaxies in the early universe, there's been a question of whether galaxies grow their mass very smoothly or if they grow in these very short bursts.
Oh, I saw this in an article about you, the burstiness of galaxies.
Oh, yeah.
Okay, that's what this means.
Yeah. So, that's exactly, it's trying to see, how galaxies are growing. So there's a big challenge to this because galaxies only really grow on time scales of 100 million years or so.
Yeah.
And,
we can't really sit around and wait for that to happen.
I don't think either of us are planning on living that long. So we have to find some other way of determining how galaxies are growing, whether it's smooth or bursty. If you're making a simulation, you can, run the time. You can make the time speed up much, much more, and you can make predictions about how one galaxy might be growing. But you can't actually look at one galaxy and tell in detail how it's you can kind of get an idea, but you can't really
ask it what happened.
You can't ask it doesn't speak English.
Dang.
So what we do is we take whole populations of galaxies. So what I do is I take a sample of galaxies, I plot on the x-axis I plot the stellar mass, that's how much mass there is in stars. And on the y-axis, I plot star formation rate. That's how many stars per year that we think it's forming.
How do we know star formation rate of galaxies?
Oh, okay. All right. So what we look at is the light coming from young stars. If we can, basically the idea is that if we can count or get a rough estimate of how many young stars are in that galaxy, then from there we can back out what the star formation rate is. If there are a lot of young stars, then the star formation rate must be really high, because young stars, and especially really massive stars, don't live that long. So if there are a lot of young massive stars, then they had to have formed very recently. Otherwise we wouldn't be seeing them. So the star formation rate must be really high. Conversely, if you have a lot of really old stars and there aren't a lot of massive young stars, then the star formation rate must be really low. Otherwise, we'd be seeing these stars.
Okay, so countries that have a lot of babies are likely growing in population.
Exactly.
Cool. Yeah. So you look for babies.
Yes, we look for stellar babies. And, okay, so here's the idea. If you have a galaxy if we think that galaxies at a certain mass should be growing at roughly the same rate, then what you'll expect is that when you plot mass versus star formation rate, it should be like kind of a very tight correlation.
Okay.
What we see, though, is that depending on how you measure the star formation rate, it'll be a very tight correlation, or it'll have some scatter to it. So that might mean that galaxies are, you might observe one galaxy that has, a much higher star formation rate than the average. You might see another galaxy of a similar mass that has a star formation rate much lower than the average. So what that would mean is that you're kind of catching galaxies in a similar stage in their evolution, but you're maybe catching one in a huge growth spurt, and then you're catching one that is, kind of in a lull in its star formation. So what we're kind of trying to find out is how dramatic are these growth spurts, and how does that change over time, and that informs a lot of stuff about, like, what kinds of physics are important to incorporate in simulations of galaxy formation and evolution, things like that.
Cool. So if we had a perfect y equals mx plus b, that's no bursts, and then the more scattered we get, it's like the more bursty.
Yep, exactly.
What do you think it's going to be if you had to throw out a random prediction?
Well, so simulations, a lot of simulations, what they're predicting, especially like higher resolution simulations, because simulating is like a whole different thing. But
are you in the simulations or mostly
I'm in the observations camp. But high resolution simulations often predict that galaxy evolution should proceed in a very bursty manner. So like star formation rate should just be swinging very, very wildly. You can't see, but I'm like
the baby booming generation.
Yeah. It would be like the baby booming generation, and then 10 years later, 5 kids were born, and then the next 10 years later, 30 million kids were born. Like maybe not quite that dramatic in orders of magnitude, but you get the idea of what I'm getting at. So the prediction, or at least my understanding of what should happen, is we should be seeing galaxies being very bursty, possibly more and more bursty as you go to earlier times in the universe.
So we've settled down.
Yeah. The idea of galaxies sort of settling down and forming stars at a more like constant, smooth rate has to do with the galaxy's mass. So I want you to imagine for a second that you have a galaxy that is, forming stars, and it's forming stars very intensely. What will happen is those young massive stars will be very bright, and light actually carries momentum. So what will happen is that radiation will actually push out all of the gas from that galaxy. And that
solar
gas,
sail.
And that gas is the fuel for star formation. So it completely starves the galaxy of its fuel for star formation, and it can't form stars anymore. So that's how you go from a really high star formation rate to just nothing. Now, if you are in a very low mass galaxy, that galaxy doesn't have a lot of gravity, so that gas kind of just goes out to infinity, and you have to wait for more gas to kind of settle back in before you can start forming stars again. But if you have a very high mass galaxy, the gravity will stop that gas from escaping, and the fuel for star formation will stay there, allowing you to sort of smoothly and continuously form stars. So one of the predictions is that if you have more massive galaxies, and by today, a lot of galaxies have built up their mass, so a lot of galaxies have reached this threshold, you're able to form stars more smoothly. But in the early universe, when galaxies haven't built up that mass, they're not able to hold on to a lot of material through gravity, you have a lot more erratic star formation behavior. So that's one of the predictions, observations. I don't quite know if we've seen that definitively in observations, but we're getting there.
So you are a graduate student, but you have clearly just unveiled a huge truth about the universe. How was your academic journey getting to this point? I mean, the things that you just said are like clearly years and years of experience and hard work.
Yeah, so it actually started, as a little kid, I was always interested in astronomy. There were these shows on the History Channel. One of them was called The Universe, and it had all of these super cool, like, astronomy animations and, like, a super dramatic narrator and, like, exploding stars and all that.
Yes, the
like,
Griffith Observatory Planetarium of it all.
Yeah, I was like, whoa!
And you're watching these from home in Minnesota?
Yep, watching them from home in Minnesota. And then in high school, I went to Minnetonka High School. They live in a bit more
Lake Minnetonka?
Yeah, it's around Lake Minnetonka. Yeah,
okay.
It's a bit more of an affluent neighborhood. My mom open enrolled me in that school because they had a lot more resources. So they actually had a research program at that high school.
For high schoolers?
Yep.
That is so cool.
Yeah, and so what I was able to do was actually work with my teacher, one of my science teachers there, Russ Durkee. He had a telescope in his backyard, and we observed variable stars and measured their brightnesses over time. And I entered a project into a science fair, and I actually got to go to the International Science and Engineering Fair in Pittsburgh in 2018. So I thought, science research is really cool. And then, I after that, I was like, well, I want to do research in college. Russ Durkee connected me with my undergraduate advisor at University of Minnesota, Twin Cities.
Oh, no way.
Claudia Scarlata.
Go, Steve Ma.
Go Gophers. Go Gophers.
Let's go Gophers.
Go Gophers.
Okay. My partner went there. He's also from Minnesota. I'm really sorry about this construction noise, but we're almost done. If you're listening to this, there was like a weird construction thing going on right outside of our recording room today.
It adds to the flavor of the episode. Yeah.
It does, and if you've been listening this far, then you really like DJ Micron and you're gonna stick around. Anyway, so you had a really great mentor. The importance of mentorship in astronomy really cannot be overstated. How did you go from undergrad at University Twin Cities to eventually coming here and working with Alice?
Yeah, so I have to mention one of my other mentors. I actually did an REU in undergrad for
we love
REUs. 2 summers in a row with Professor Bob Benjamin. He's a faculty at UW Whitewater, but also works at UW-Madison. And I got to do a project on the Milky Way with him. But he was a really great advisor, not only for like science, but also just on an interpersonal level. So I think, like you say, like the mentorship aspect of having somebody who really understands the importance and the impact of mentorship and how that can really uplift the next generation is super important. So he was really instrumental in the development of my undergraduate studies and my ability to get into UCLA. Also, Claudia Scarlata, she worked very hard to make sure that my application going into grad school was competitive, because she knew kind of that the state of things now, it's really hard to get into grad school. So she made sure, she was like, all right, we're going to have like a first author publication for you, and we're going to she said, we're going to do this, and we're going to make sure that you're all set. And so also have to, really attribute my success to her foresight in that sense.
That is amazing. Applying to grad school is like a sport.
It is. Oh my goodness. Yeah, I remember, because not only was I applying to grad school, I was also working as an RA.
Okay. You were busy.
I was busy. I was taking like several classes at a time. I graduated in 3 years. I still don't know how I did it.
That's crazy.
Yeah, and then I was doing something else. Oh yeah, I was also applying to the NSF GRFP.
Oh yeah,
and
the
that
GRFP.
was like that was a whole thing.
I have gotten 2 perfect scores and never been recommended.
Yeah.
The GRFP hates me.
Oh yeah, no, that's the first time they were just kind of like no, and then the second time they're like, wow, that was great. We'll give you an honorable mention.
So you have an HM.
Yeah. But yeah, it's just really hard. Like if you read the essays that are successful, it's like, wow, these are like the bar is set very high.
Yes, absolutely.
But yeah, and so after that, I got into grad school, started working with Professor Alice Shapley, and again, she's been a wonderful mentor. So I feel like along every step of the way, I've been just blessed with like such wonderful people serving as mentors for me, and it's allowed me to sort of maintain my passion for astronomy and pursue what I love to do.
That's great. I have had very similar experiences. I have now had 3 mentors that have all just given me uncountable amounts of opportunities and just like the best guidance ever. So on the note of mentorship, I'm sure part of why you volunteer for EYU, give up some of your very valuable time, is to mentor the next generation. If the small version of DJ Micron was at EYU speaking to an adult, maybe like you or me, what would you have wanted to hear?
Yeah, I remember you asked this question and I made a mental note to try to answer it, and then we got carried away.
I warn everybody, and then nobody ever does it. They're always like, this question's so great, and by the time we get here, they have nothing to say.
Yeah, well, let me think.
It's okay. Join the crowd.
I don't know. I feel like I would just, be the adult that interacts with him and asks him all about astronomy, all about the things that he loves about astronomy, and I would tell him, never allow somebody else to make you feel like you are stupid, or make you feel like this is something that you can't do, or make you feel like you can't pursue something that you enjoy because you're inadequate. This sort of phenomenon of imposter syndrome is so common in STEM fields for various reasons, but I think one thing that I've seen over and over again is that a lot of the people who are like really second guessing themselves and like really unsure of themselves are actually very intelligent people and should be a bit more confident and sure of themselves because they tend to have the best ideas. And the people who are a bit more overconfident and sort of domineering and have a bit more of a commanding presence doesn't necessarily mean that they're the best scientists out there or that they have the best ideas. So what I would say is just really trust your internal compass. You've got a great head on your shoulders, and don't let anybody tell you otherwise.
Absolutely. Skepticism is a huge part of science. So if you're a self-skeptic, that just means you're a good scientist.
Yeah, exactly.
That was really well said. Is there anything else you would like to share with our audience?
I would say stay curious. If you like astronomy, just keep following news. I'm biased towards the James Webb Space Telescope, so keep following the news on new discoveries with the James Webb Space Telescope. There's a YouTuber named Becky Smithers. She does really good public outreach with regards to astrophysics. So I would direct you to her YouTube channel as a starting place, and if you see any news articles that say scientists disprove the Big Bang again, then you can already click away from that article because they probably are just trying to sell a sensational headline. So
the clickbait is real, but where can people click on your stuff?
Well, if you would like to, scroll through the Astrophysics Journal and look up my name, Leonardo Clarke, and read some of the introductions, or if you're an astrophysicist and want to read more about my papers, you can find my papers online. I also have an Instagram page at nebula_nightscapes. That's where I do like astrophotography.
I love that.
I haven't
I'll
done
definitely
it.
Be following.
Yeah, I haven't done it in a while, but hopefully I'll be uploading more stuff there soon.
Well, thank you so much for joining us, DJ Micron, and sorry again about the background noise. I think your talk was great, and hopefully this inspires everybody to go to the UCLA Planetarium. I don't need to tell the EYU visitors to go to the Planetarium. They will do that. But to the rest of you, we are all going to be there this fall on Wednesdays at 8 p.m.
Looking forward to seeing you there.
Thank you so much again, and thank you all for listening. With that, never stop exploring.
It's just really hard. Like if you read the essays that are successful, it's like, wow, these are like the bar is set very high.
Yes, absolutely.
So, but yeah, and so after that, I got into grad school, started working with Professor Alice Shapley, and again, she's been a wonderful mentor. So I feel like along every step of the way, I've been just blessed with like such wonderful people serving as mentors for me, and it's allowed me to sort of maintain my passion for astronomy and pursue what I love to do.
That's great. I have had very similar experiences. I have now had 3 mentors that have all just given me uncountable amounts of opportunities and just like the best guidance ever. So on the note of mentorship, I'm sure part of why you volunteer for EYU, give up some of your very valuable time, is to mentor the next generation. If the small version of DJ Micron was at EYU speaking to an adult, maybe like you or me, what would you have wanted to hear?
Yeah, I remember you asked this question and I made a mental note to try to answer it, and then we got carried away.
I warn everybody, and then nobody ever does it. They're always like, this question's so great, and by the time we get here, they have nothing to say.
Yeah, well, let me think.
It's okay. Join the crowd.
I don't know. I feel like I would just, you know, be the adult that interacts with him and asks him all about astronomy, all about the things that he loves about astronomy, and tells him to, you know, never. I would tell him, you know, never allow somebody else to make you feel like you are stupid, or make you feel like this is something that you can't do, or make you feel like you can't pursue something that you enjoy because you're inadequate. I think this sort of phenomenon of imposter syndrome is so common in STEM fields for various reasons, but I think one thing that I've seen over and over again is that a lot of the people who are like really second guessing themselves and like really unsure of themselves are actually